Welcome to the lesson on operation on decimals. Today we will discuss some of the basic operations that we can do and how they will translate to more complex operations later in future math courses. Like numbers and decimals can be compared, computed, and converted. So first we think about some of the comparisons. Like any number, I can look at a decimal and think that 3.5 is going to be larger than 3.4. That 5 in the tens place being bigger than the 4 tells me that 3.5 is bigger. If I take a look at two other examples, 8.51 is going to be greater than just an 8.5. Even though the 0 is not there, it still means it's smaller. But what if the numbers are bigger? Again, I take my big example and I line it up. If I have 3.21564, I take a look at how the numbers all line up. Looking at the 6 and the 3, I realize that main difference right there, and the 6 being larger, tells me that that number on top is bigger. With this next example, I take a look at all the matching zeros until I get to the instance where the 6 is larger than the 0. Even though the 6 is still after a 0, it still means that this top number is the larger of the two quantities. Now we take a look at computations. Adding or subtracting numbers with decimals is done easily after lining up the decimal place. With this in mind, we follow much of our same addition and subtraction properties. Looking at our first example, we imagine 2.34 plus 1.8. I can write the 2.34 and underneath it I write the 1.8. And I add them and will simply vertically add. I include a 0 there so that it lines up easily with the 4. And then I add as I would numbers without decimals. 4 plus 0 is 0, 3 plus 8 is 11, put the 1 on top of the 2, and I get 4.14. Here's my final answer. As long as I kept the decimal place in the same spot, I should be fine. Subtraction should follow the same principle. 7.20 minus 4.05, and I can subtract things vertically. I only will add or subtract the numbers that are vertically lined up with each other. In this case, I take 1 away from the 2, make the 0 a 10. I have 5, a 1, and a 7 minus 4 is going to give me 3, and the final answer is 3.15. When we take a look at converting decimals, we're really thinking about how we can take a fraction and make it into a decimal. Case in point, we look at 1.5 and how we translate that into the 0.5 that we know it is. So looking at an example, let's take 1/2. Well, the fraction 1/2 means 1 divided by 2. So if we take a look at this and set it up as a standard division problem with our long division bar, it'll give us some insight in how we do it. So 1 divided by 2. Now 2 does not go into 1, so we need to make that 1 a 10. And remember to include the decimal place. 2 goes into 10 5 times, and when we do 2 times 5, we get 10. Retain the decimal place that we had with the 10, and we get our answer of 0.5. Now that's an easy one. Let's take a look at 5/8, or 5 divided by 8. So same thing, 8 on the outside, 5 underneath the long division bar. Now 8 does not go into 5 regularly, so we need to make that a 0, add a decimal, and now we continue to add zeros so that we can get numbers. 8 will go into 56 times, that gives us a 48, leaving us with a 2, drop another 0 down. 8 goes into 22 times, 8 times 2 is going to give me 16, and even though my problem does not go on for too much longer, for the sake of time, if we take a look and we were to continue, we would end up with a 5 and a final answer of 0.625. So a decimal with 3 places as a decimal version of our fraction 5/8. The connection is very strong. We think about decimals and what we can do with them so that we can ultimately address money, we can address data, and greater sense into the world of math.